Hey, hey. So today we're going to look at different observations we can make with quadratics. Now again, a lot of the stuff that you're going to see in this unit is going to be familiar. We're just going to be applying it a little bit differently than we have so far. So a lot of this is review. So when we begin, it says identify the vertex, axis of symmetry, and intercepts. Okay. So I'm going to go ahead and go in order. So first, identify the vertex. Cool beans. So my vertex, right at the peak of my parabola, is right there. So here is the vertex of my fire hose water path. Okay, our vertex is 20, 24. Check. All right, now our axis of symmetry. Well, the axis of symmetry cuts through the vertex. So the axis of symmetry is x equals, well, what's the x? 20. Check. And now let's look at our intercepts. Well, remember, intercepts, we have two kinds. We have x-intercepts and y-intercepts. So I'm going to go ahead and look when I first start reading my graph right here at 0, 4. This is my y-intercept. And as I follow my graph, my parabola comes back down. Boom. At 42, 0. And this is our x-intercept. Remember, x-intercept can be called x-intercept, root, a zero, a solution. So we got lots of words for that one. All right, so intercepts. Check and check. Cool. So when is the graph increasing or decreasing? Okay, so again, how do we read a graph? This is super important. Just like we read a book, left to right. So when I first look at my graph, I see it is going up. So my graph is increasing from, now again, this is how we read a graph. So it's increasing. A lot of people want to tell me from 4 to 24. No. How do we read? Left to right. So we're looking at that x-axis. So it's all about the independent variable. We are increasing from 0 to 20. All right, and we're increasing from 0 to 20. Remember, 20 is going to be included in the increasing and decreasing interval, so I don't want to use equal to. However, 0 is only included in the increasing, so I can use equal to for this one. All right, and then we start decreasing from 20 to 42. So we are decreasing from 20 to 42. Okay, again, 20 is that pivot point, so it can't be equal to, but 42 is only in the increasing, so it can be included. So x is less than or equal to 42 or greater than 20, and that is where we are decreasing. Perfect. Increasing and decreasing. Check. All right, now what's the domain and range? Okay. So again, let's review. Domain. Who is the domain referring to? Well, the domain, that's all of our input values, our x's. So what is the minimum x? 0 when we start. And then what's the maximum x? Well, how far does the water path go? 42, feet. So x is between 0, and 42. Is this inclusive? Sure. It starts at 0 and stops at 42. We're not sharing it with anybody. All right, this can also be written in set notation or interval notation. Now, set notation is the one that looks just like this, but we put that x such that and put it in the curly brackets. So that's one way. Or we can write it in interval notation from 0 to 42, both included. So now let's look at the range. Okay, so the range, that's talking about our y values. So my y values are between, well, what's the minimum vertical height? Well, when it hits the ground, 0, and then what's the maximum? 24. And that range is including, it does hit the ground and it does hit the 24 feet. And we can write it in interval notation from 0 to 24. I am not picky in a testing situation how you write it, unless there are specific directions that say write it using interval notation or write it using set notation. Okay, so domain and range, check. All right, now here is something new. It wants us to write a function rule for the water path. Okay, this is no longer linear. Okay, we have a quadratic function. So we have standard form and we have vertex form. Oh, we also have factored form as well. We don't know what the factored form is because I'm not really sure what my other 0 is, so that doesn't help. So standard form, A and C, I know my y-intercept is 4, that's C, but I don't know what A and B are. So the easiest way is to use vertex form. Wait, what? Yeah, vertex form. You'll remember. That's where f of x equals A times x minus h squared plus k. Remember, we did this when we did transformations, when we had a graph and we shifted it left, right, up, down. This helped us do that. So if we're going to write a function rule, we're going to use vertex form. Now, why did I choose to use vertex form? Well, I'm so glad you asked, because I know what my vertex is. My vertex is 2024, and our vertex is our HK. So that's my H and my K. Cool. So if I go to plug everything in, I can fill in, oh, sorry. My H and my K. So remember, this minus x minus h can also be written, or read, opposite. So the opposite of h, so h is positive 20, so we are going to do minus 20, and k is a positive 24. Okay. So there's some information, however, I still have an f of x, an a, and an x. All right, well, I know my vertex, and remember, f of x is just a fancy way of saying what? Y. So that's our dependent variable. Well, I have tons of x's and y's on this graph. So I'm going to use one because the biggest thing is we need to solve for a. So I'm going to pick a nice, easy point. How about 0, 4? I love when 0 is involved because it's 0 and it usually helps us cancel out. So 0, 4. Well, what's 0 and what's 4? 0 is my x, 4 is my y. So I'm going to replace y with 4 and my x with 0 And we're going to solve for a. Cool? You're probably thinking, no, Mr. Humphrey, not cool. It's okay. We only have one variable. Let's just follow PEMDAS and we can solve for a. So I'm going to start with these parentheses. So 4 equals a times 0 minus 20. So negative 20 squared plus 24. Okay. Oh, that's 20, not 2. So now we square. So negative 20 squared gives us 400. So we have a 400. Yeah, how about a times 400? That sounds better. All right, equals, and we have bring down the 4 and bring down our positive 24. Okay, so let's solve. Again, we're solving for a. So I need to isolate a times 400 and plus 24. So I'm going to kind of PEMDAS in reverse. So I'm going to subtract 24, cancel that out first. So 4 minus 24 gives us negative 20 equals a times 400. So now I'm going to cancel out this 500. I'm going to divide both sides by 400. So a equals, cancel those, negative 2 and 40, negative 1/20. Okay, so to put it in vertex form, f of x equals, we found our a term is negative 1/20, sorry. Oh, I guess I should stick with yellow. And x, and again, we already know our vertex, so x minus 20 squared plus 24. So it asked us to write a function rule for the water path. Boom. I knew my a term had to be negative because look at my quadratic. It's frowning, it's sad, so a has to be negative. But we had no idea it was negative 1/20, so you have to plug in and solve for your a. So f of x equals negative 1/20 times the quantity x minus 20 squared plus 24. Now yes, I do realize that that takes a little bit, and no, you do not have to do this 10 times, okay? This would be like a one-time thing. All right. So let's go on. The graph of a quadratic function is shown below. Cool beans. Which statements about the graph are true? Select all that apply. All right, so let's just do one by one. The graph has a y-intercept at 0, 8. Well, let's go identify. 0, 8. 0, 8. Yes, that is in fact on our y-axis. Correct. All right. The graph has a maximum point at negative 1, 9. Negative 1, 9. There's our max. We're on a roll. All right, so the graph has an x-intercept at 2, 0. So 2, 0, 2, 0. That is an x-intercept. Yep. Wow. Are there going to be any wrong? So the graph's line of symmetry is the y-axis. Well, where does our line of symmetry or our axis of symmetry, it can be called either, where does that cut through? The axis of symmetry, that cuts through the vertex. So my axis of symmetry is not the y-axis. It's actually x equals negative 1. So that's not true. Okay, so the graph has zeros of negative 4 and 2. Well, what are zeros? Zeros, roots, x-intercepts. Yes, and yes. Negative 4 and 2. Perfect. All right, the graph represents the function f of x equals negative times the quantity x minus 1 squared plus 9. Okay, so I look at A and it says negative 1. Well, I know it's supposed to be negative. I don't exactly know if it's 1. I will teach you how to find that later. But let's see what our vertex is. So we said our vertex is negative 1, 9. Negative 1, 9. That looks pretty good, right? Oh, I hope you said no. Remember, if anything is going on inside those parentheses, it must be opposite. So this should actually say x plus 1 squared plus 9. And this A term, just for a little trivia, it is negative 1, and is that correct? Yes. How do I know? Because if I go to my vertex, if I go over 1 unit, I go down 1 unit. So whatever your first movement is, like when you move either left or right, your first movement, depending on how many you go up or down, that is your A term. So that's another way to look at that. Awesome. Great job, guys. Go ahead and try a couple on your own and come back and see me.